So hey guys, we are going to discuss question number 852, peak index in a mountain array. So basically what this question is asking, we are given array ARR where we have to return index of the peak element or the greatest element. For example, in this array you can see this is the greatest element. So you have to return its index, example 1. Okay? Or for visual explanation you can see 0 will be somewhere here, 10 will be at the top position in terms of metric, 5 will be here, 2 will be somewhere before 0, should be here. Okay, so if you see this is a mountain forming and you have to return the index of the peak element, and in the question it is given for sure there will be a peak element. You have to just simply return. Okay, the thing is you just simply thought, okay, we'll just traverse to array, you'll keep track of maximum element and its index, at last you'll return the index of that element. But the question is not simple as that. As in this question you have asked, instead of big O of n, you have to do it in log n of time complexity. In big O of n you can think of prefix suffix sum. Okay, the other thing you can think of, just as I said, keeping track of the index of maximum value. So I'll say how you'll approach the problem as how to get intuition, you can say. Simple thing to get intuition for this problem is like you have to find an element, and you have to find an element in log n of time complexity. Which algorithms help you to find the element in log n time complexity? The answer is binary search. You will use binary search. How you will use binary search? Let me give you an example. Let me take another example so I can do more iteration. For example, this is your array. Okay, binary search code, you know, like I'm just explaining you. This you'll use a 2 pointer starting and ending. Okay, or left, right, you whatever you want. You'll find value of mid. I am writing the formula: mid equals to start plus end minus start by 2. This will be a formula, and these are your indices. What you'll do, simply first you'll find the mid. Initially your mid will be 1, so this will be your mid. What you'll do, you check if the value at the right hand side of this mid is greater. If the value at the right hand side is greater, what does it mean? If you check if the value is on the right hand side is greater, there's a higher probability that our answer is in the right hand side. And you can see in this array also, right hand side is greater than the mid, so answer is in this side. Yes, so what you'll do, simply you change the s and you'll update it to mid. Okay, wait, or you can say mid plus 1. You'll update your starting index here. Okay, again you'll find a mid equals to starting 2 plus 3 minus 2, which will be 1 by 2, which will be 2. So your mid will be here. Okay, simply here will be pointing to this second index. Then what will you do? You check if the right hand value is greater. No, 2 is not greater than 10, so you won't update this. So there is a chance that our answer is lying, rather than on right side, it is in the left side, left side of mid. So you'll update your ending index, you point it to here. Okay, as you can see, starting and ending coincides. So what you do, you simply return starting index. So this was the question. I hope you understand. The main thing was to get intuition for big O of log n time complexity, and to find an integer which is greatest, or to find a value, you will use this binary search. One more thing, binary search works in sorted array also and almost sorted array also. And I hope this is useful. Like and subscribe to my YouTube channel. Bye bye.
I don't believe in destiny, I just do what's best for me. Don't listen to my enemies.